A very good evening, everybody. Welcome back. It's really heartening to note that more and more people are joining this forum, and we've also receiving good reviews on this. Please keep it up. Please keep joining, and we will continue this activity that we have started off, the three of us collaborating and trying to provide you with the best knowledge base with reference to cracking the interview skills. So on that note, let us start. All right. Now, excuse me. So for the last 2 days, we have tried to do a kind of a role play wherein we had Sharath play the role of a person who thinks he knows everything and then fumbles up the answers, and then Barney is the person who gives the correct answer. So I think that role play this is a continuous evolution process. So what we are doing is we are going to take a pause with that role play and see if both the interviewees, I'm going to remain the interviewer, both the interviewees, when I ask them the questions, let us see how they complement each other with reference to the responses. And that way you'll be able to get not just one right answer, but two right answers or two better answers. So in that context, we are going to have the strategy today. And the topic for today is, kind of data pre-processing and the allied areas in that. So I'll once again start with Sharath, because I've always done that with Sharath. So Mr. Sharath, welcome. So my first question is with reference to the project that you were discussing. So I just want to know if the data was imbalanced or balanced.
Thank you, Nitin. Good evening, everyone, and thanks for the opportunity, Nitin. The project that I worked on, just to give a quick gist on or the recap of the work that we have done, is basically to predict the cost of a vehicle. So the business wanted to have an appropriate cost for the second sales of the car. But in order to do that, we did not have any labeled data. So we thought of creating a correlation between the mileage of the vehicle and then map that to the cost of the vehicle. So this mapping is obviously done by the clients themselves based on a subjective decision and experience they have taken. But to come to that area, we have predicted the mileage of the vehicle. That is like performance of the vehicle. To work on this particular use case, we had the sample data. We took close to 2,500 records, and we had around 10 columns. And the output column that we were working on was a continuous variable, that is the mileage per gallon. And when we verified the distribution of this particular continuous variable, it was observed that this is non-normal. We had a few exceptional cases, and we had to deal with those exceptional cases, and we tried to analyze the normality of the data. And because it was not normal, we couldn't work with random sampling techniques. We had to first treat this, ensure that it was converted to make it normal by using various transformation techniques. We did try manual transformation techniques, and we also tried Johnson technique and Box-Cox techniques as well to be very sure that the outcome that we are getting, the data that we were receiving after transformation was very, very perfect with respect to the scope of that work that we were doing. And once it was normally distributed, the transformed data, we used that, which basically was giving us a balanced data split. I hope that answers your question.
Yeah, thank you. Thank you so much, Sharath. Yeah, that's a pretty detailed answer. So Barney, in the context of your project, would you like to elaborate further or, add on to what Sharath has already said?
Yeah, absolutely, Nitin. So our project that we have worked upon was to predict whether a person will default on the loan or not. That's loan defaulter prediction model. So the output variable that we were dealing with had two categories: default, not default. And when we looked at the split, proportion of default and proportion of not default, we figured out that 90% of the people were falling into the category of not default, and 10% of the people were falling into the category of default. And going by the thumb rule, if we have one of these classes, that is default or not default, if we have one of these two classes having less than 30% entries, then this data set would be called as imbalanced data set. And very clearly, since one of the classes, the default classes, were approximately 10% of the entire data set, our data set was classified, or we categorized this as imbalanced data set. And then we have applied imbalance techniques on this data set. So when we moved on to the model building phase, if it was balanced, we would have done a split as training and test using a random sampling technique. But for us, since the underlying data was imbalanced, we have applied techniques such as SMOT, modified SMOT. We tried out undersampling, oversampling, k-fold cross-validation, and bunch of techniques which should ideally be applied when it comes to imbalanced datasets. Yep. Thank you so much, Nitin.
Sorry, thank you, Bernie, for the response there. Yeah. So, audience, what we have heard here is two, unique scenarios. One, Sharath spoke about continuous output, and there is also the scenario. There is also a phenomena of imbalance when we have continuous output as well. Imbalance does not always mean 70-30. Imbalance can also mean that you have a very long tail. So you have, or you can have, it can be not normal, non-normal distributions, etc. You can have, bivariate kind of a data where you may have some kind of clusterings present inside your output variable. So all these things can result or can be classified as as a scenario of imbalance. And like Barney has taken the more traditional, I mean, his case was the more traditional one where he spoke about the categorical outputs where there were a very, very clear-cut scenario of 90:10, which was an imbalanced, and what was done to address the same. Now, my follow-up question, because this is very interesting, what basically Sharath has mentioned, because not many people know this, and therefore, when somebody answers this rightly, the interviewer is obviously going to be very excited and try to probe further. So my follow-up question to Sharath is, okay, your data is imbalanced. Okay, you have made the data, your data is not normal, which is a case of imbalance. Okay, your data, you have transformed it and made it all right. Why? What if you hadn't done it? What is the implication of the data being not normal in the context of your project? Your answer, please.
Nitin, just to explain that point, imagine that we are working on the real world scenarios, and the statistics world, and in fact, the entire world runs on a simple logic, which basically says that everything is normal. And if we can identify pattern from a normal data, then we will be able to try and apply our statistically based models, which are predefined, of course, thanks to our statisticians. We will be able to apply those logics and try and define the pattern which is there in the data. But if our data is not normal, which basically means that it is abnormal, if the data is abnormal, we will not be able to use a lot of statistical techniques to identify the patterns which are probably there in that particular data. And just to ensure that these abnormalities are removed, and we can try and generalize the entire data to replicate the original business problem scenario, we have to transform it. And the scenario is that we cannot have any biased techniques while we are choosing our training data, test data, or any new data that we get. We have to be choosing a random sampling techniques, which basically are called as probability sampling techniques. So if I have to apply this simple random sampling technique, which is the de facto technique, the SRS is what we call it as, our data has to have a normal distribution. This is the reason why we have to ensure that our variables, which are not normal, are transformed to normal.
Thank you, Sharath. Barney, you'd like to add further on that? In the context of continuous data, would you like to add further? Not your project.
Absolutely. Yeah. Absolutely. So when you have an output variable which is continuous in nature or which is numeric in nature, to decide whether your data set is balanced or imbalanced, you need to do a normality test. That is, you need to determine whether the output variable is normal or non-normal. If it is normal, then all good. You can just apply simple random sampling technique to proceed further with splitting your data into training and test, or training, validation, and test based on the need. However, if your data are non-normal, you first try to transform it and make it normal. If it's normal, once again, you apply your simple random sampling techniques. But what, despite transformation, your data are still non-normal. Then you need to proceed further with different sampling techniques, such as k-fold cross-validation, leave one out cross-validation, which is not widely used, but yep, this is another technique. And then you have techniques such as SMOT, modified SMOT, so on and so forth. So different sampling techniques should be applied if your underlying data are imbalanced, as opposed to your underlying data being balanced. Yeah, thank you.
All right. So sum it up specifically while we're talking about the continuous data, because I'm sure most of you are aware about imbalance in categorical data. To sum it up about the continuous data, if it is simple rule of the thumb, if it is normal, well and good, use simple random sampling. If it is not normal, try to make it normal and use simple random sampling. Even after trying to make it normal by transformation techniques, you're not able to make it normal, your data still is non-normal, you will have to use modified sampling techniques like, SMOT, M-SMOT, you have k-fold cross-validation, various other things that is mentioned, you'll have to use those methods. So if you give all these three things in the answer, you can be sure that that ends there. The interviewer is not going to ask you anything after that. Thank you, both of you. So we'll move on. Okay. This is again, we'll continue with the discussion with reference to the balance and imbalance. So how does one categorize, or how does one know about balance and imbalance in multi-categorical data? Barney, you can go first this time.
Yeah, sure. So when your output variable is continuous, normality test. When your output variable is categorical in two categories, then we have a thumb rule that if one of the classes is less than 30%, then it's imbalanced. That is pretty straightforward. But when it comes to multi-categorical data, there is no defined thumb rule as such. So it goes by the general intelligence. Let me take example of 4 classes. If someone takes a loan, maybe they would repay the loan ahead of time or exactly on time, or they might delay the loan submission or loan payment, or they might default. So if there are 4 categories which exist, and then say all 4 categories have approximately 20 to 25%, 25%, 25%, 25, and 25 in all the 4 categories. In this kind of scenario, it's straightforward balanced. If one of the classes is 10%, then remaining 3 are 30%, 30%, 30% each. Then very clearly, in comparison to the other categories, one category is very less. So this would be classified as imbalanced data set. However, having said that, it might be really tricky when it comes to multi-categorical data to determine whether your data are imbalanced or not. So we would experiment, assuming that our data set are balanced, do your simple random sampling, build your models, and build another algorithm or build algorithms, assuming that your underlying data set are imbalanced. And then apply all these oversampling, undersampling kind of techniques and build your algorithms. Then you look at the accuracies of these two scenarios. One scenario is assuming your data are balanced. Another scenario is assuming your data are imbalanced. Look at the accuracies and then figure out which approach is giving you good accuracy. Go with that.
Great. Thank you, Barney. And I'd just like to quickly add another thing that I have. Of course, I'm supposed to be the interviewer, so I shouldn't be giving answers, but nevertheless, I got excited. So another simple policy that you can do if you have multi-class data, and if among the classes you verify or find out the class which has the least proportion. So like Barney said, 30, 30, 30, and 10. So the class which has the least proportion in the entire data, take the count of that particular class, and you can do, undersampling from the remaining classes. So effectively, if I have 100 records and 30 records of one class, 30 records of one class, 30 records of one class, and 10 records of one class, for my sampling, for the purpose of, taking the data which I'll eventually partition for train and test, I will take the entire 10 records of the minority, randomly sample among the 30 another 10, randomly sample another 30 another 10, randomly sample from the other 30 10. So I now have 40 records with 25:25:25:25% proportion. I have now done an oversampling in comparison to the class which is having very less categories. So this is one thumb rule. But again, there is a risk to this. If your data itself is very less, you only have, let us say, 500 records. You have to use the entire 500 records. So you'll have to think over again. So it is, again, as a data scientist, over a period of time, you will be able to do it. Yeah. Okay. So next, we will discuss about, so let me just move on to the other topic here. All right. So what is the difference between longitudinal and time series data? This question is to Sharath.
Thank you, Nitin. Once again, let me start with time series data set. The simple fact is the data will be in series format. When I say series, it's basically a sequential data. And the thumb rule to detect a time series is that it is a univariate data set. When I say univariate data set, we will have only one column which is of our interest. We also can call that as a variable of interest. And this data is being collected in sequence of time. The granularity at which the sequence is collected is, of course, again, subjective and depends on the business requirements. It could be minutes basis, hour basis, day basis, or weekly basis, so on and so forth. But as I said, it is a univariate data. The thumb rules are single column collected in sequence. Now coming to the longitudinal data, which is also called as a panel data, is basically a data which has multiple columns, but all these columns are also collected in sequence. So it's a combination of what we call as a cross-sectional data, which is generally collected in random fashion. And the combination along with that, we also have the data which collected in sequence. So we take all these randomly collected multiple variables and arrange them in sequence of time. So it's a multivariate data which is collected in sequence is basically called as longitudinal data or panel data.
Barney, anything to add, please? With reference?
Yeah, absolutely, Nitin. I would probably rephrase the same explanation which Sharath has given, but okay, let me give an example here. Suppose you have a column called as sales. And if you have the sales data collected for each and every month, as an example, Jan, Feb, March, April, May, June, in that sequence, then it is called as time series data. We're talking about a single column. Say you collected the sales data for Jan 22, Feb 22, March 22, April 22, May 22, so on and so forth. It's called as time series data. What is longitudinal data? If I collect the same sales for Hyderabad region, sales for Bengaluru region, sales for Chennai, and then if I collect the sales for all these three locations for Jan 22, Feb 22, March 22, April 22, etc., then this would be called as longitudinal data or panel data. In panel data or longitudinal data, you will have multiple columns which are collected based on time series in that sequence. Whereas in time series, you will have a single column, which is also collected based on time series fashion. Yeah.
Thank you so much. So just one small addition I'll also like to make. The examples now, every question, every interview that you attend, you should have a good understanding of who your company is, who the interviewer is. And therefore, if you have to give examples, if possible, try to give examples related to their company. Now, if you're attending interview for a pharmaceutical company, then pharmaceutical trials or something like that, you can probably use examples. This impresses them further than generic examples, because if the question is not related to your project. Okay, so that is one thing. Thank you so much, both of you, for the responses. So let me now move on to Sharad. Okay, now we're discussing about data pre-processing, and we discussed about balance and balance. But there are many names that data pre-processing is given. Many names that data pre-processing is given. So can you please spell out some of those names?
Oh yeah, gladly. Yeah, before that, I would just want to summarize the process. So when we talk about data pre-processing, the idea is to ensure that the data is in an appropriate format for us to move to the next phase, which is model development. And model development is basically a concept which is kind of bringing up mathematical concepts onto the programming concepts. And of course, business logic. So your data has to be in a structured format, which your computer can understand, on which your programs can be written. And then it would become very easy for us to take the mathematical concepts and apply them on this particular data. So in short, data pre-processing is a step where we do a lot of manipulation, adjustments to the data in generic terminology. And from a statistical world or data analytics or data science world, the terminologies goes as data cleaning. We call it as data pre-processing or data preparation. We call it as data munging. We call it as data wrangling or data organizing. We can also call it as scaling. We can also call it as data transformations, so on and so forth.
Okay, thank you. Thank you so much. I really doubt if Barney has anything to, add to that. He has used all the things. So I'll leave it at that.
It's like, Nitin, if I may intervene, I can call you as Nitin, or I can call you Mishraji, or I can call you Nitin Mishra, all mean the same. Right? That is exactly what Sharad would say.
Yeah, amazing. Thank you so much, Sharad. All right. So we have time for one more question. So again, I'll give it to Sharad first, and then I'd request Barney to give a follow up on that. So what is the sequence that one would follow for data pre-processing? Any project, a generic project that we have, the step one, step two, I request an answer for that.
Okay, as such, Mr. Nitin, there is no standard process or standard flow that we have to follow. It purely is a subjective call that one should take based on the characteristics of the data that we are dealing with or data that we are able to ingest into Python. But if you have to very generic manner in its ideal conditions, if I have to put the order, then probably I'll start with trying to understand whether Python has, or that would be my go-to programming language for analyzing the data. So whether that particular programming language has correctly interpreted the data that we are trying to load is the first thing that I would like to look at. And this is basically called as typecasting. Because Python has this capability where it can automatically interpret the data types. So I just wanted to cross-check whether this interpretation is in line with the understanding of the data from business perspective. Post that, I would also like to check if there are any duplicates. There are a lot of cases where the data can be duplicated. We don't want to work on duplicate data. Post that, I would also want to perform univariate analysis, where we will try and look at the outlier analysis. Then we also look at checking the variations in the data using zero variance logic. I also want to treat missing data if there are any. And if I have to convert the data from, let's say, very large data, continuous data into discrete, then we'll do binning. It's also called as discretization. Then I also want to do encoding. There are different techniques that we will implement based on, again, the characteristics of the data. We'll try to convert non-numeric data into numeric form. This specific process is called as encoding. And we can also talk about transformations. We can talk about scaling. So on and so forth. These are probably an ideal steps that we can try and apply for cleaning our data.
Thank you, Sharath. Barney, your go.
Yeah, Nitin. So it's like buffet. Data pre-processing is like a buffet. You have a lot of items. What do you want to consume first depends on you as a person who prefers to eat something. For example, I would probably get started with sweet because I have a lot of cravings towards sweet. And not many people would do that, right? They will probably start with soup and so on and so forth. Given this, a data scientist has all these arms and ammunitions of data pre-processing. They can choose based on what they want to apply. However, having said this, there is a sequence that we can talk about, like typecasting. Then we have something called as handling the duplicates, because you don't want the duplicate data. Then you probably deal with your outliers, remove your outliers from the data. Then you perform zero variance imputation and categorization or discretization, as people famously call it, transformation, so on and so forth. But yep, there are once again no defined steps, as in what should come first, what should come second, what should come third. But then based on our experience, we can say that our mind map, which is available on 360 website, has the steps which has to be followed in that sequence for majority of the projects, and it will work well.
Thank you so much, Barney and Sharath. Thank you for this session today. It was, I believe, a lot more engaging because we could address a lot more questions because we changed the format. So, audience, the takeaways for you is that you need to have your knowledge. You need to have threadbare knowledge, and like Barney wrapped up in the end about the mind map, because if you can look into the mind map in great detail, you'll be able to answer just about everything. So what we've kind of discussed is very, very simple thing about imbalanced data, all right, and how it can be with reference to continuous and multi-categories. We've also discussed with reference to longitudinal and time series, a simple scenario there. And then, of course, the stages or the steps that one needs to do as part of data pre-processing. Use your experience of your project that you have done and how you have, and justify the sequence with how you have done it because of that reason. So, Barney, any closing remarks?
Yep, absolutely. So, friends, at the end of 1 week, Monday to Friday, Monday to Friday, all the Monday to Friday, we'll be having these kind of interview preparation sessions. And the mind map is being created by Sharath as we talk. PDF document is being created by Nitin. Both of these are available on our website, but we'll give you the exact location of that on probably Saturday. And it'll be posted on our LinkedIn homepage. So please, there's a link which is posted of LinkedIn. Please follow our page so that you get to know about further details of this mind map, etc. And also we recommend you strongly to follow our YouTube channel, because the deployment tools would be discussed on every Saturday. Every Saturday, we are also going to talk about one deployment tool, which will be predominantly driven by Sharath and me supporting him, and Nitin will be overseeing the session. Thank you so much, and thank you, Nitin. Thank you, Sharath. Thank you.
Thank you, Sharath. Thank you, Bernie. Bye.
Thank you, everyone. Happy learning.
Please subscribe to our YouTube channel and click on the bell icon. Thank you.